So audio is okay. Finally, we have planned a short session to reflect the lessons learned of our project. Therefore, we have extended now our round, and the format will be that every partner representative can give his own opinion on this contribution to the energy transition. And yeah, so it's a free discussion, starting with Stefan. Do you like to start for that, for example? And yeah, we are limited in time, so we quickly go through it. Yeah.
Thank you. So as I was mentioning in my talk, Ethan was involved in two areas. One is the MVDC, and we were collaborating briefly with HYPERRIDE. Practically, HYPERRIDE is developing a more mature and more developed circuit breaker for 5 kilovolt, and is actually all the way to testing in Aachen. In our case, we are looking at a higher voltage, slightly different use case, but we are much earlier in our direction. So practically, we have some lesson learned from that. It's very important to at least in MVDC, where you don't have a lot of ready products, commercial products. It's very important that you are actually using the existing technologies, but at the same time, the scaling up is not straightforward. So a certain technology can be taken forward by the owner of the technology. So, for example, HYPERRIDE can spend the time to develop for 14 kilovolts, as we were mentioning, but at the same time, the competitive landscape in industry is practically says that the competitors, the companies that are working in this direction will also have to take into account own ideas, as we have some own ideas that we are working on, and this is actually will come with its own set of challenges. So it needs the lesson that we learned in this is that the development of a medium voltage circuit breaker, even if you have experience in low voltage DC circuit breaker, we have in Eton some experience in the direction, is still a lengthy and a challenging project that needs to be taken into account. This being said, we will by the end of the project, we will show our proof of concept, and we will demonstrate in laboratory measurements, but this will be much less in terms of technology readiness level than the solution that HYPERRIDE is demonstrating. And this is in one of the directions. The other direction is the low voltage DC. In this case, we are a little more advanced, as I was mentioning. We have several projects in which we are involved with low voltage DC. So we have certain experience. We have corrected a lot of challenges. I mean, we have approach a lot of challenges and tackle them for the low voltage DC distribution. However, even if what we learned from the practical demonstration, and we have here Massimo as a witness to this, we have learned that actually unforeseen challenges, unforeseen problems can appear in the practical implementation. Even if you are trying to repeat, you are saying, okay, we have developed this, but we also want to implement again very similar solution in a different setup that can actually prove challenging as well. The evolution, the continuous evolution of the technology. So being a new DC microgrid and DC components are fairly new on the market. So the providers are continuously developing and producing new versions, and that is actually posing a challenge. So all this needs to be taken into account when going for a practical demonstration. Even though, as I was mentioning before, we have some experience with that. We have worked with the power system and control in several use cases and pilots. There's still a lot of challenges. So practically, we can confirm that the development of commercial ready solutions is not an easy task, and it in a way justifies what the evolution of and penetration of DC power system is slower than we would like. And I think this is our main challenges in the two directions, our main lesson learned. So we can discuss more if you have particular questions about this, but I guess I can now give the give the microphone to somebody else.
Yeah, thank you very much, Stefan, for your opinion or your feedback from a big manufacturing side. Happy to have you on board, and yeah, maybe I can continue with the technical issues and university
Yes.
side.
Yes, Stefan, actually, I would like to continue your statement more or less, because the lessons learned on RWTH Aachen side are that, I mean, first of all, it's possible already today to operate hybrid AC/DC, and even medium voltage to low voltage DC substations. But the focus in the future should be to develop and implement systems that are set up for multi-vendor interoperability. So what we achieved in Aachen was to adapt all of the converters that we had, to adapt all the controls and all the communication to achieve interoperability for our system. What we need to ensure that we can develop and implement systems that are interoperable in the future without touching every control aspect or every measurement. So with that being said,
yeah, thank you for this. I can only confirm, yeah, as a standardization is a big issue for the future, starting with LVDC, but also in the next step on MVDC levels.
Yeah. Do you want to answer more on this aspect of?
Yes, in the low voltage is the key in the revolution, I think, because if we, the key word is smart grid. Smart grid is, I think, an approach, a different approach in the concept of distribution, because the smart grid already exists many years that it exists in high voltage to regulate the frequency and the connection in all the European countries already exists. So the smart grid in high voltage exists. It doesn't exist in medium and low voltage. And fuel electric home and energy community and prosumers, aggregators, all these words speaks about the users and the small producers, the private, the citizens that must participate in managing the energy. And in this approach, in this new approach of market, but not only, also cultural approach, in participating the citizen in the energy managing, it passes through, I think, the hybrid, because converters and are amazing devices that burns native digital. In the distribution, in the low voltage, we have a circuit breaker, very easy. And we have some controllers, and we have also smart meters that acquire the measure every 15 minutes, but the 15 minutes is very too long time to manage energy. And in DC, we can use the fine tuning in converters, and the match is between the transformers, the AC transformers, and converters. In converters, it wins because we have many possibility to get measure in real time to fine tuning different. If I have to change energy in AC, I have to have an outages and to go there in the substation, and with the screw, I change the connection physically, and we come back to smart grid, and this is I think the loop that make the hybrid AC/DC grid the winner for the future. If we solve the problem that Stefan told, but are less problem because many years ago when I degreed at the university, the problem was the interruption of the DC current, that it doesn't pass through the zero, and it was the problem in a small inductive current, and it's very difficult to do this. But now I told to bench in Schiebreck that, and in Aachen and Eton that are working in this technology. So I think that it's the time to do this transition.
Yeah, I think to jump in on this topic of transition from AC to DC, I think there's also another point that we presented here. We presented technologies in terms of circuit breakers, technologies on cybersecurity, technologies of converters. I think one of the main point about this at the power system level or at the power grid level is that we, in the end, need to talk the same language. So we need to be able to, like, a power grid or power system person would probably not understand what a converter is at the level of refinement that we power electronics engineers understand it. So we power electronics engineers need to develop a converter that is so reliable and so good in terms of quality that they can just see it as a current source, a voltage source, a droop controller, or whatever it is, just a very simple system. And this is where the challenge is right now. I mean, all the technologies that we have for medium voltage, for low voltage exist or can be developed in terms of, I mean, maybe medium voltage circuit breaker is still like a small thing, but we are almost there. You've seen already the presentation, it exists. Or, I mean, cybersecurity aspects also, the technologies are there. It needs to be combined together and put it in a way that even people who don't understand IT, people who don't understand power electronics can put it together. And this is where the DC is challenging, because DC needs converters. DC needs some new technologies that power systems are not used to. They are used to transformers. They are used to very simple, very robust systems, and we need to provide the same technology or the same reliability. So this is also, I think, a challenge. I mean, I've experienced this at our side at a research level where, I mean, power electronics and power system were working together, and we struggled so much on this grid reconfiguration because we had to work together, and sometimes problems are occurring and you don't know if it's a power electronics problem, so mainly a converter problem, or if it's a power system problem, mainly his control. So there is those two things where we need to say, okay, this is reliable and I can trust it for upper level operation.
Yeah, thank you for this input, Jules. I can only add, we already have in the existing AC systems converters which have implemented several grid supporting functions. So power electronics in the grids, in the distribution grids, is not new. but I agree. Next step should be standardization and to make this technology for the end users like plug and play systems, yeah, with automated systems which need not specialists to operate it. Yeah.
I just want to, sorry, well, just one comment to what Jules said. Indeed, there are some let's say end of the line steps that we need to take in certain areas. But however, we, at least from our point of view, we cannot say that the solution is there. Or everything is solved. We just need to tweak some aspects. It's practically, we know the way to go, even in hybrid circuit breaker, in low voltage DC circuit breaker, or control or thing like that. But nevertheless, it seems like this last 10%, let's say, of the effort is very, very complicated, very difficult. That's why we are trying. I just wanted to react to this because we are trying to avoid, or at least we don't say think this the technology there, so practically the problem is solved. We don't see like that. We see that there's still work to be done, and we still have challenges. Although great progress was done, nevertheless, towards reliable, exactly, I agree completely with you. When you say reliable, easy to use components are still let's say an objective. We are not there yet in most situations where we can just take off the shelf and use it anywhere. So sorry.
Yeah, thank you for this contributions. Maybe.
You have talked about the simplicity of usage, of interoperability of the things. I couldn't agree more, because also from the ICT point of view, there are still a lack of standards in many cases. And I also can also speak about what have been said also in the opening keynote of the conference, in which things seems to be already available, and the fact that they can be combined easily to each other, and the only thing is just deliverable, also for me is not the only problem. The solution can be approached from the ICT point of view with the at least de facto standard, so not official standard. So the standard that are used more with respect to the other. Following this, you can have the possibility of proposing something new, integrated, something new, if not ready off the shelf yet, but an advancement on that, also from the ICT.
Yeah, definitely. This is an important point. Don't wait for standards. Also the world, the big inventions first were put in place. Operative experience was collected, and then it was brought in a bigger rollout and commercialization. So this is also one message. Standards are important for commercialization, but it works also the other way around, at least at start.
Hi. Yes, my key notes. I wanted to take it from another perspective, because yesterday I've been listening to many presentations here at the ENLIT, and I really saved in my head two key points that Europe is trying to address. On the one side is the use of energy, of renewables. We want the energy to be used as soon as it is produced, and if it's not possible, to be stored, because we don't want to curtail renewable energy. Point two was that there are a lot of regions in Europe where the grid is not ready to host more renewables. So going back to 2.1, storing of renewable and smart use of renewables, I would like to make a comparison, because we're asking the users to consume the renewables when they are produced, so adapting the grid tariffs and so on. And we are building up storages in which the renewables is produced in DC, is transformed in AC, then back to DC, and then put in a storage, which is a very inefficient way. And I wanted to do this comparison. I remember when I lived in Italy, I was asked not to. I had the bad habit brushing my teeth to keep the water on, and I was asked, don't waste water. So I tried to. I started turning it off while I was brushing it, just to turning it on back while I was using it. And then I found out the pipes of Rome, the city where I lived, are damaged. And we have a lot of losses. Even if I use it, when I use 1 liter, like there is another liter that is lost within the pipes. And this is exactly what the HYPERRIDE concepts try to address. We're trying to shift the consumption of the users. We're trying to increase the storage. But all these processes with this transformation AC/DC are inefficient. And we're asking the end user to change their habits. But the process behind is still not efficient. So we have to address it. And AC/DC grids can address it, can make it more efficient. And yes, and as the simulation, going back to 2.2, the simulations have also shown that doing this, also the hosting capacity increase. So we would be able to install more renewables to store them more efficiently. And in the end, the conclusion is that we can reduce emissions. And as we could see, if we balance the cost reductions among users, we can make it viable and realistic, reliable.
So summarized, energy transition is triggered by the low voltage levels. Also, this is also somehow was at the beginning not well received from politics side or from regulation, but I think, and I can also speak for Austria, for example, actually there's also it's also visible that the distribution grids are driving the energy transition. And as maybe final comment, projects like HYPERRIDE and others are levers how to deal with this energy transition from technology side. And last but not least, it has been driven by the market, by manufacturers like Eaton, partner, and accepted by the customers, for example, ASM Terni. And we contribute in the fact that we try to make stakeholders confident on this technology and manufacturers to step in and drive the market. So this will be the last demonstration project or innovation action in EU landscape. There are coming up a lot of other new projects based on these learnings of our project. And yeah, this is a continuous transition path, and I'm happy to follow that within the next upcoming years. So thank you very much, centers, for the visitors via the Teams and our Zoom link for the hybridization, and yeah, enjoy ENLIT conference. Thank you very much.